Welcome to Lesson 4 of Nginx Advanced Mastery. Let's talk transport. HTTP2 and HTTP3 solve the same problem, fetching dozens of resources without paying for dozens of round trips. H2 multiplexes everything over one TCP and TLS connection. H3 throws TCP out entirely, runs on UDP via QUIC, and kills head-of-line blocking on lossy networks. Both ship with one config change, and Alt-SVC is the header that bridges them, letting clients discover H3 and upgrade gracefully. Here's the lay of the land in 4 pieces. H2 is one line. Append HTTP2 to your Listen 443 directive, and you're done. It's been universal in browsers since 2016. H3 needs Nginx 1.25 or newer compiled with the v3 module, plus UDP 443 open at the firewall. Alt-SVC is the handshake that tells clients to try H3 next time, and the honest decision rule, H2 always, H3 when the network itself is the bottleneck, mobile, lossy links, or latency-sensitive traffic. Data center only? H2 alone gets you 90% of the win. Look at the stack layer by layer and the story tells itself. HTTP 1.1 burned 6 TCP connections per page and still head-of-line blocked at every layer. H2 fixed it at the application, one connection, multiplexed streams, HPAC headers, but TCP underneath still stalls every stream on a single lost packet. H3 throws TCP out, runs over UDP with QUIC, and bakes TLS 1.3 plus 0 RTT directly into the transport. Each generation pushes the fix one layer deeper until there's no layer left to blame. So let's start with the cheapest of those wins. On any TLS server block you already run, add the word HTTP2 to the listen directive, reload Nginx, and you're done. Browsers pick it up automatically through ALPN during the handshake. No client changes, no flags. What you get back is one TCP connection per origin instead of 6, multiplexed streams over it, and HPAC shrinking your headers by around 85%. Skip server push. It's deprecated since 2022. Use preload links instead. Rule of thumb, enable it everywhere. Zero risk, measurable gains on mobile. H3 is a bigger lift, but not by much. You need Nginx 1.25 or newer with the QUIC module compiled in. Ubuntu's default package ships 1.24, so pull from the official Nginx repo or build with HTTP v3del module. Then open UDP 443 on the firewall because QUIC rides on UDP, not TCP. Add a second listen line, listen 443 QUIC reuse port, alongside your existing HTTP2 line, pin TLS to 1.3 since QUIC requires it, reload, and verify with curl HTTP3. Same port, 2 transports, side by side. Now here's the catch. Even with H3 listening, browsers will keep using H2 unless you actively advertise the upgrade. That's what Alt-SVC does. One line, add header Alt-SVC H3S 443. MA 86400 always, and every H2 response tells the client, hey, I also speak H3 on the same port. Remember that for 24 hours. Next request, the browser tries QUIC. If UDP is blocked, it silently falls back to H2. No errors, no user impact, just a graceful upgrade path. And don't forget the always flag, so the header ships on error responses too. So here's everything stitched into one server block. 2 listen lines on 443 TCP for H1.1 and H2, 2 more on 443 UDP with QUIC and reuse port for H3. Same cert, same route, same location. TLS 1.2 and 1.3 because QUIC mandates 1.3. Then the Alt-SVC header upgrades H2 clients to H3, and HSTS locks everything to HTTPS. Old browsers negotiate down to H1.1, modern ones land on H3, and you maintain exactly one VOST. Now zoom out. Why does any of this exist? One problem, solved at progressively lower layers. Head-of-line blocking. HTTP 1.1 had no answer. 6 parallel connections still meant 14 round trips for 80 resources. H2 fixed the application layer with multiplexing and HPAC, but TCP's in-order delivery meant one lost packet still stalled every stream. H3 went lower, replaced TCP with QUIC over UDP, made loss per stream, and threw in zero RTT and connection migration for free. Each generation fixes the bottleneck the last one exposed. So here's the cheat sheet. Print it, pin it. 5-star directives are non-negotiable. Listen on 4 and 43 with HTTP2, SSL protocols, TLS v1.3, and the alt SVC header to advertise H3 to your H2 clients. Add listen quick reuse port and quick retry when you're ready for HTTP3 in production. HTTP2 or max concurrent streams you'll basically never touch. The default is fine. SL early data is the zero RTT lever, worth it on latency-sensitive endpoints. Skip it where replay matters. Time to put hands on keys. 3 drills, escalating in scope. Exercise 1. 10 minutes to flip H2 on an existing site and watch the waterfall collapse in DevTools. Exercise 2 is the big one. 30 minutes to install Nginx 1.25 from the official repo and bring up HTTP bit3 over QUIC, verified with curl 8. Exercise 3 closes the loop. Add alt SVC, load the page twice, and watch Chrome upgrade from H2 to H3 between requests. You need a real domain and a real cert. Reuse the $XYZ from Beginner Lesson 10. Read the hints before you start. They cover the gotchas that eat the most time. Before you start the labs, here are the 5 mistakes that will eat your afternoon. 1. Nginx opens UDP 443 internally, but your firewall doesn't. H3 listens, nothing arrives. Browsers fall back to H2 silently. 2. Forget reuse port, and a single worker swallows all QUIC traffic. 3. SSL protocols without TLS 1.3. Handshakes fail with no clear error. 4. Don't hardcode H3 in clients. Let alt SVC and the browser negotiate, or corporate UDP blocks will time you out. 5. Add header. Alt SVC needs the always parameter, otherwise a 502 strips the header and the browser forgets H3 exists. Every fix is one line. You just have to know to look. That's the lesson. 3 protocols, 1 config block, and a stack that's ready for whatever the next 5 years of transport throws at it. H2 stays your universal baseline, H3 picks up the slack on lossy mobile networks, and alt SVC quietly stitches them together. Next up, Lesson 5 takes Nginx beyond HTTP entirely. The stream module, TCP and UDP load balancing for Postgres, Redis, MQTT, different block, different rules. See you there.